If I had to choose a single word to encapsulate the essence of SpaceX, flexing Starship Flight 3, SpaceX quickly mobilized its resources to address the encountered issues and prepare for the next launch. With an estimated time frame of 6 weeks, SpaceX set the goal of achieving readiness for Flight 4. They will have new modifications for Ship 29 and Booster 11 specifically, which I'm confident is necessary for SpaceX to make sure that the launch goes smoothly. These new designs are based on the issues we've identified from the process. First, there's a change to the grid fins of the booster. This stems from the landing process, which highlighted an important area that needs improvement in SpaceX's Starship program. During the landing process, B-10 exhibited significant instability. As we can see from reviewing this video segment, the grid fins were rolled in an uncontrollable manner. So, what could be the cause? SpaceX has not made any announcements regarding this issue, but regulations. The incident with the grid fins may be related to the control capabilities in its drive system. Actuators serve as the bowl for controlling the movement of grid fins, enabling adjustments in pitch, yaw, and roll. The choice of power sources for these actuators is crucial. The company adopted an electronic steering system, no hydraulic fluid here, to adjust the fins. However, it's been unstable in having to replace the actuator on the net fin. Another possible cause that could make the grid fins widely fluctuate is electrical supply interruption. The 4 grid fins are electrically activated and powered by the ship's batteries to operate this system a few years back. However, this also can't prevent issues from arising with this type of battery. Special type of control surface, slaps or rudder. On both SpaceX and Super Heavy booster and Falcon 9's first stage booster, grid fins are used to provide aerodynamic pitch, yaw, and roll control to the booster while it's falling back to Earth through the atmosphere. Fins are odd in that while they're relatively flat, they actually represent a fairly large fin surface area. Because they're essentially comprised of tens of small surface area, all adds up. On Falcon 9, they're primarily used because during ascent, the grid fin can be folded down, making less surface area to the oncoming airflow during ascent. This reduces drag and rocket more efficient. On Super Heavy, there are 4 grid fins weighing 3 metric tons each, or 6,600 pounds, which is about 20 times heavier than the Falcon 9 grid fins. Base estimate that I found of 140 kilograms for Falcon 9. The grid fins don't fold as a folding mechanism would add weight complexity, aka cost. Their simulations also indicate that the grid fins shouldn't have much of an impact on Super Heavy's efficiency during ascent. This is due to Super Heavy just being much bigger than Falcon 9, that the square-cubed law makes aerodynamic drag contribute much as that the engines have to fight against, with the sheer mass of the rocket and gravity drag being a lot more consequential. This component will be one of the things that SpaceX definitely needs to pay attention to in the next Starship flight. It may change based on the issues encountered in Starship's Flight 3, or could involve optimization, as Elon's previously stated. Elon Musk mentioned that they are very over-engineered, or in some sense, not engineered at all. They know how grid fins work from Falcon 9, so they decided to go with grid fins in order to accelerate development, and basically make them large and thick, with the option to reduce or replace them later when they gather more data. He mentioned they could probably be made larger, even staying with the same profile, but most likely they could also be made smaller. You'd only need 3, not 4, and the third one could be a lot smaller than the other 2. This is why the new design of B-11 is truly something to look forward to. How do you think its fins could change? Comment down below so we can all discuss. Another issue we noted is Raptor engines. It may have landed too late because the booster caught fire just 1 kilometer above the ground. We see that 3 engines tried to ignite, but it seems like the booster engines didn't show any reasonable difference in deceleration, so the process didn't occur. At T plus 652 minutes, pay close attention. We can see an object flying up from below and hitting the grid fin, peeling off the paint. That object is a piece of the engine base shielding that was dislodged when the Raptor started malfunctioning, or the engine was damaged due to tremendous force during the return at speeds of over 4,000 thrusts to activate the landing process accurately. Therefore, the Raptor engines are also a challenging issue for SpaceX, forcing them to review their technical methods for installing the 33 engines of the booster. So, how about Starship 29? How will its design change to ensure the success of Starship's 4th flight? In reality, SpaceX did not raise many issues with Starship Stage 2 during the launch from the intense heat generated during re-entry into Earth's atmosphere. However, concerns have been raised regarding the retention of shield tiles during re-entry, with instances of the tiles falling off observed during previous missions. The core issue here lies in the process of attaching the TPS tiles, evidenced by the pre-attachment of these protective components. Discovering relatively intact TPS blocks near the launch site, despite the vibrations and pressures during launch, suggests that their detachment may be due to loosely tightened bolts or damaged clip heads. With 18,000 tiles packed tightly together, a possibility is that stacking, destacking, tanking, detanking, and thermal expansion are the culprits causing the tiles to start wiggling loose before it launches. With multiple attachment points, all the pins would need to cooperate in this process. If one's stubborn, it causes the tile to fail rather than to simply slip its bonds. Now, we still don't know how the tiles will perform under the pressure of re-entry. However, I believe SpaceX will handle the heat well due to thermal management efforts. However, even the best tile won't help if they come loose. We need to test to see if they can withstand the stresses of re-entry. If they can, then the issue might be with the fasteners. For now, though, the tiles should be fine for Starship until SpaceX finds better options. Adding to the changes of the Ship 29 is the functionality of the payload bay door. This component seems to have not fulfilled its mission as SpaceX tweeted. The door still hasn't performed the opening and closing properly, and it even popped open during the spacecraft's flight in space. Yikes. We've analyzed this thoroughly in a previously published video, so if you're interested, click to find this video on our YouTube channel. Finally, the redesigned new Starship is also predicted to incorporate an attitude control system that'll work well to keep the spacecraft stable while gliding with its wings. It's called the Reaction Control System, abbreviated as RCS. This system's already been implemented in the initial phase of Starship, so these control units could actually be unusable right now. It just needs to be completed by adding position control units. As usual, everything takes longer than expected. This also means that currently only the new booster has the new design. The spacecraft will get refurbished in a subsequent update. As SpaceX continues to analyze and learn from previous flights, addressing these challenges will be crucial to improve and optimize the Starship program. By identifying and rectifying the inherent weaknesses in components and attachment processes, SpaceX aims to enhance the reliability and performance of the spacecraft for future missions. Please look forward to a new shiny Starship on their next flight. SpaceX is a giant in the field of private space exploration, and they continue to surprise us throughout their operations. Right now is no exception. SpaceX and Elon Musk have finally unveiled the design of the new Starship prototype V3, unlike any other vision, and that gives us a clearer view of the remarkable upgrades it brings. So, what has Elon just revealed about the new Starship V3? What makes it so impressive? What's the difference between Starship V3 and V2 and V1? Starship is currently the largest rocket ever built by humankind, including the first stage named Super Heavy, standing over 120 meters tall in total. SpaceX has conducted 3 orbital test flights so far. 2 took place in 2023, and the last one was in March, which was very successful. But Elon's company is now researching something even bigger. These are Starship V2 and V3, presented in the presentation slides. How will these guys differ from the current test design? First, you can see that Starship V2 is slightly taller than the current prototype, with the spacecraft's height increased by an additional 2 meters and the booster's height increased by 1.3 meters. The increased load-bearing capacity and thrust during liftoff enable it to carry more than 100 tons. The new version of Super Heavy is expected to provide about 15% more thrust than the booster used in the March test. In fact, Starship 2 will be the first version of SpaceX's rocket to operate fully and allow it to deliver cargo into space. Elon declared that SpaceX launched more cargo into space than missions conducted by other companies or nations. When Starship can fly regularly, the success rate increases to 99%. However, looking at Starship 3, this is when some upgrades really come into play for a much taller spacecraft that looks like a clearly elongated version. With the thrust expected to be improved paired to Starship V1 and V2, Starship V3 could increase from 7,000 tons of thrust of V1 to over 8,000 tons of thrust for V2, and eventually over 10,000 tons of thrust for V3, as Elon shared during the presentation. This results in the payload capacity of Starship V3 doubling that of Starship V2, exceeding 200 tons, surpassing all current vehicles. Starship V3 will stand at 150 meters tall instead of 124.4 meters of Starship V2 and 121.3 meters of V1. And it may be taller than the current launch tower at Boca Chica. At that size, the 2 stages of Starship V3 are nearly identical. The fins also look slightly larger and may even be fixed in place. With these improvements, Starship V3 will accommodate 4,050 tons of fuel in the booster and 2,300 tons ship, larger than the 3,650 tons in the booster and 1,500 tons in Starship V2. In terms of engine count, V3 will feature 6 engines and 3 additional vacuum engines. Starship V2 and V1 will maintain 3 sea-level engines and 3 vacuum engines aboard. Another feature that we notice is the hot staging section of Starship V2 and Starship V3 differing from Starship V1. Instead of the original style vent hole design, now the new version of Starship has an interface similar to the Soviet N1 style of the interstage that's incorporated on board. This has sparked much debate about the endurance of the increased gravitational force on Starship's capabilities when subjected to very high pressures during flight. However, these are just predictions, and we have to wait and see what SpaceX does next. And also in the graphic images, the various versions of Starship have shown us the answer to the speculation of the past when Elon Musk hinted about the version of Starship. At that time, we speculated that the initial lengthened Starship would be part of the rumored V3 lineup that's currently in the design phase. Starship V2 will be produced and might get skipped. However, this is no longer accurate, as Elon and SpaceX are definitely going to manufacture Starship V2 later this year and launch him by 2025. This could lead us to speculate that Starship V3 could potentially be manufactured in early 2025 and ready to go in 2026. Of course, this isn't merely speculation, as we've recently seen the first hardware components of the new version of Starship at the build site, proving that SpaceX is ramping up work on Starship V2. Alongside the impressive capabilities of the new version of Starship, Elon Musk also mentioned another very important aspect that Starship will undoubtedly achieve in the future, which is maximizing cost reduction. Musk claimed that the future Starship V3 would cost less to launch than SpaceX's original rocket, the Falcon 1.
These are sort of unthinkable numbers.
He said,
nobody ever thought that this was possible, but we're not breaking any physics to achieve this.
Well, this is beyond our imagination. For instance, if a future Starship costs $2 million to build and $2 million for fuel and operations, then even in expended mode, the payload cost would be $15 a kilogram. Now, considering a $3 million Starship capable of flying thousands of times, the cost would primarily revolve just around the fuel expenses for the flight and minimal overhead. By implementing systems for synthesizing liquid oxygen on site, fuel costs would be substantially reduced. For example, with an estimated $500,000 per orbital flight for fuel and 250 tons of reusable payload, the cost would range from $2 to $4 a kilogram. Similarly, for transcontinental flights, with fuel costs estimated around 125 Gs per flight and the same payload capacity, the cost would be around 50 cents to $1 per kilogram. And
so that's the difference between if you've got a fully reusable rocket with low-cost propellant and autogenous pressurization.
Doing launch services, it's emerged as one of the most important. Nowadays, humans have more opportunities to access space thanks to Starship, and this isn't just leaps and bounds achievable only by billionaires, but it's an opportunity for all of us. Starship will have resupply missions to the ISS will be the first steps, followed by sending humans beyond Earth to the Moon and even Mars. As early as 2026, Starship is slated for a lunar mission under a contract with NASA. Starship's reusability and cost savings align with the agency's goal of establishing a more human presence on the Moon, making it a stepping stone for the future. Moreover, Starship itself will be the first outpost on these distant planets. Government planners won't have to worry too much about the emergence of Starship, as it'll serve as a home on the Moon or Mars. Beyond interplanetary aspirations, Starship also revolutionizes transportation here on Earth. With its enormous capacity and rapid speed, the new version of Starship will expand transportation opportunities from one point to another, reducing transit times between distant points, of course, with a reasonable price and Starship being available to everyone, whether government or private entities. First, commercial orbital stations will create more opportunities to host tourists. Second, tourists are going to be able to fly on Starship itself. And there are already more flights from SpaceX. The first mission, called Polaris Dawn, is scheduled to launch a 4-person crew led by Isaacman in 2024 with the company's Falcon 9 rocket and Crew Dragon spacecraft. Polaris Dawn's the inaugural of up to 3 planned missions, with a final one to be the first crewed spaceflight of SpaceX's Starship rocket. Each such new rocket system makes space a little more accessible to all of us, and the time is not too far away when flights into space will be as affordable as airplane flights. Everything is amazing, isn't it? But in reality, as Starship continues to get upgraded, it'll have even more advantages than we think. Those will be important steps for Starship to get closer to these important goals. It won't only reinforce SpaceX's dominance, but also be a huge benefit for NASA and the U.S. aerospace industry. It can be said that the changes with Starship V3 are truly breaking every limit we can think of. Not simply the limit of the size of a rocket, but it'll be the limit of exploration that humans aim for, beyond